Alright, so binary and sequential or linear searching algorithm. Basically, searching is the process of determining whether a given value exists in a data structure or storage medium, which basically means you just are looking for a value in an array. And the two methods that I'll be covering in this Prezi will be a linear search and a binary search. Basically, a linear search is used to sequentially scan an array. So if you have any given array of values and you input a search value, it would sequentially, or I guess chronologically in a sense, search through the array. So compare one value by one value by one value. Thus, linear searching.
Okay.
So the, I guess, catch, or the benefit to linear search over binary searching is that linear searches can be applied to both unsorted and sorted arrays, whereas a binary search can only be applied to a sorted array.
That's an extremely important point. Okay?
So this is just some code that I found off of Wikipedia for a linear search. And basically, a loop would be made, and you'd input a key that you'd search, or that you'd want to search for in an array of k. And then once you find the k, you would return it, or if you could not find k, you return -1. Binary search uses a recursive method to search an array to find the specified value. So basically, if you find the value, it is returned, or if you do not find it, -1 is returned.
But like you said, with a binary search, you need to make sure that the array is sorted first before you could use this algorithm.
Right. Because basically, if you have like an array of 9 values, in a sense, binary searching would pick maybe value 5, and it would compare the given value and see if value 5 was greater than or less than the said value, and if it was less than, it searched the values. In a sense, it'd be like a pivot. So it searched ones before or after it. So once again, the array must be sorted. If the value looked for smaller, then yeah, the second half of the array could be ignored. So yeah, it's exactly like Fraz's quicksort method. So once again, just going over. So the pseudocode, which I also found online, would be something like this. So here you would, this would be the value you're searching for. So it would search.
And what do you mean approximate midpoint?
Approximate midpoint, because once again you have to do computations to find the midpoint. So, like a pivot, the better value would be to search for one in the middle. So you won't always have exactly the middle.
Right, like if you have an even amount of numbers in an array, for example.
Yeah, like the median would be a better word.
Okay.
So here you would input a mid, or mid would be inputted, and basically if key equals mid, then it would return the mid and search through it. If not, it wouldn't search it, I should say, because
that's it.
Because that is it. And if not, then it would search the half that's greater than it, or the half that's lower than it.
Well, how does it determine which half it searches?
Because if the mid is, well, to begin with,
it's greater or less than.
Yeah.
Because this is for, remember, sorted algorithms.
Right.
Yeah.
Sorted data.
So this is the actual code. It's just basically restating what I said. So here, it would add the first and the last points and divide it by 2 to find the median. Yeah.
So there is the case where you have an even amount of numbers in an array, for example.
Yeah. So, yeah.
It's exactly like this.
So here, there is no infinite recursion because each stopping case performs the correct action for that. Correct action for that case. Each stopping case. So each stopping case would be like, if you can find the value, then if you can find the value in one half, or if it's not the middle, if you can find the value it would return your correct value or it would return -1. So there's no chance for infinite recursion because it will always return something. -1 or your value. That makes
Okay,
sense.
so it's done properly. What you're
Yeah.
saying is it's,
I'm just restating.
right, there's no chance for you to get stuck in an infinite loop or something like that.
Yeah. So something that I didn't go over in this Prezi was the big O value, and the big O value of a binary search in the best case scenario would be the log of 1, whereas in the worst case scenario or on average case scenario would be the log of n. Yeah.
Yeah.
Because
Typically, when you're discussing big O values, you're discussing, at least on the exam, it pertains, Michael, only to sorting algorithms. You could discuss the efficiency of a search algorithm, but the big O values questions that I've seen on the AP exam
Mostly for sorting.
pertain to sorting, not searching.
May I play that again?
Is it
It's
relevant to your presentation?
Absolutely.
Okay.
So it's gonna explain the procedure.
This is binary search, okay?
Yeah.
So it's sorted.
So basically, it's gonna give each of these values like a number for its position, and the midpoint is going to be 5. So m would equal 5 here, and it search the first half of the array for 75, and if it couldn't find it there, then it's in the last half. Search the last half of the array for 75, and 75 is 7.
So it disregards the first half of the array, it just searches the second half,
Yeah.
because
Right.
75 is greater than the midpoint.
Correct.
Because it's sorted.
Wait, so it can tell if there was 75 was going in the first half?
Yeah.
Of
Yeah.
course, because it's sorted. So why can't it tell it's in the first?
It
I
doesn't.
mean, the second half.
It doesn't,
It does.
it doesn't know. It's trying to find it in the second half, because it knows it's not in the first half, because
It
all the
already
numbers,
checked the first half. Okay.
because all the numbers in the first half are too small, so it's not gonna be in the first half.
It's not searching every number, Stephen. It's just searching the
Relevant half.
right.
It's like the pivot a quick sort. I think that's about it.
Okay.
Okay.
What language is that exactly? Begin and
It's probably pseudocode.
That is pseudocode.
Yeah, that looks like pseudocode.